Hi, everybody. Okay, good thing I don't have your pictures here. Okay, third form. All right. And again, like I said, with the homework that I just collected, we'll at the end cover 7, 8, 9, 10. I think some of you people out there, when I made the comment about first hour, like, oh, I'm in the same boat. I didn't show any work, and blah blah blah. Only had a few hands say that they did have like 3, 4 steps on that, and so on and so forth. It might be good. We are doing a third form today, but just remind yourself of the other two forms and how they look different. So obviously the first one is vertex form. The second one is intercept form, which is X intercept form. Okay, so top left, vertex, remember what it looks like. They both have parentheses, but the parentheses are different, and you need to make those differences in your head. You need to understand, the difference between what each one gives, I guess. All right. Then right below, this is going to be repetitive. I'm going to go ahead and have you write standard form. Again, for note takers, take what you need. You probably don't need this middle section again of the parent function, but I'm going to use that to kind of talk about the standard form. So you got your vertex form, you got your intercept form. Here is standard. You should already know what standard form is. Don't say should, Mr. Samuelus. That was from our factoring. Remember, standard form was just in descending order, x squared, x, and then constant, and then we factored it, we tried to. That's where chapter 4 is going to come into play. We're going to put the graphing and the factoring together in chapter 4 for solving purposes. So chapter 3 is graphing, chapter 4 is solving, chapter 2 is factoring, all right? And then factoring is going to be a big component for solving. So there you go. No parentheses. You just got a listing of the variables in descending order. That's standard form. Now to graph this, we're going to need something special, all right? And we'll come to that when we get to it. I'm not going to jump ahead of myself. Let me hide this. Boom. Okay, and then you don't need to write this down, but the parent function, of course, for all of these is just the f of x equals x squared with nothing happening to it. 1 in front, no other variables, no x's, no constant. That's the parent function. Input, say it. Okay, so if I input 0 into the parent, 0 squared is 0. Input output, there is the vertex. Input output, 1 squared is 1, 2 squared is 4. Negative 1 squared is 1. Negative 2 squared is 4. So there is that symmetry or symmetric relationship that we're going to use. We're actually going to use symmetry more for our evaluation, for making our table of values. You really should use this idea of symmetry. So the axis of symmetry is x equals. This is just hammering the point that it's not just 0. You don't say the axis of symmetry is 0. You say it's x equals 0 because that's a vertical line. The equation of a vertical line is always x equals a number. All right? Hammer this point down. These are the things that I will have to mark you wrong if you do not do the correct mathematical syntax, is what those words are. And it passes through the vertex. It's really the x coordinate of the vertex that's most important. But yeah. So again, if these are all things you know, just scratch a couple, things down. It's not really a big deal. All of the forms are based off of the parent function when we use, when we talk about attributes of it. Then I think you can synthesize this big, long, ugly chart that I have up here next to the important components and make it a little bit smaller. I think I have an idea that we're, maybe tomorrow. I got to see what our plan was. I actually have to meet with the teachers tomorrow too to plan the next week out, which is a good thing. But we definitely have a day where we deal with all the forms. I had an idea of maybe printing you these charts, and then you fill them in again, and then you have this nice printed copy of all the forms in front of you. I might not even need a full page. It might be a half page front and back. The key components and how what we're supposed to know. I definitely synthesize this because it's all the same. And notice what I put up here. Sorry. And I forgot to say this first hour. Let me highlight this. We're going to have a day where we can toggle between the 3 forms. So I could put something that's in vertex form. I could certainly put it in standard form. All right. And then it might require chapter 4 stuff. But through factoring, if this is in standard form and it's factorable, guess what? Then you can put it in intercept form. But the point I was going to make is no matter what, A would be the same, no matter what form you looked at the same parabola. So pretend this was the same parabola that graphed exactly the same. If I knew the x-intercepts, I could put it right away in this form. If I knew the vertex, I could put it in this form. And then standard form is just standard form all multiplied out, really. But no matter what, A would be the same, all right? So that's something to make a point of if I was dealing with the same parabola in different forms, the 3 different. So of course, if A is positive, then it opens up. If A is negative, then it opens down. Do you need to write that? It's up to you. Shorthand it though, all right, and make it fast. And then of course, same old, same old. If A is greater than 1, then it is stretched vertically. If it is less than 1, it is shrunk vertically. Same old, same old. Same effect as the other 2 forms. So this is nothing new. But I'll give you a second to write those down. I would not write every full sentence out there. Okay? Like back in the day when I used this for regular algebra 2, because it's the same. It used to be called algebra 2. Still living in the past on that one, I guess. But we would break this down, but it's good to have all that writing. Now, here's what's coming out of left field. Phew. Okay, for standard form, this is a formula. Everyone pay attention, especially if you're not and you're kind of living in your own world right now. I know sometimes students do drift off. We all have a little bit of ADD, all of us. It is true. I do. I know for a fact I do. So focus on this and just listen to what I say. This is a formula. You have to have this memorized. I don't have a way of deriving this for you to make you understand where this comes from. So here it comes. When you're dealing with standard form, the axis of symmetry is the opposite of B over 2A. It's a formula. And only when you're in standard form, when you have ax squared plus bx plus c, shall this be used. Are you raising your hand? Because there's really no question here. This is the formula. But go ahead. What's that again? Huh? Oh, you got to pay attention, dude, and stick with us, man. But it's the same. It's the same as the others. Okay, if A is greater than 1, then it's stretched vertically. If it's less than 1, it shrinks. Okay, but now back to this. And I guess I could scroll back down here. What's A, B, and C? It's right here. And I'm going to highlight this. Here's A. That's where it goes. Whatever that number is, it goes down in the bottom of this formula because it is a formula. And then what's B? It's the number in front of the X. And that goes up on the top. Then, like I said, there is no Y to a formula. There just is. And you just need to memorize it. There is no I don't get it. There is memorize it and use it. And it works. And have faith in it. And sometimes we do have to do that. Okay? So I'll zoom back into this. Hey, and then by the way, since the axis of symmetry is x equals that number, what does the axis of symmetry always go through? The vertex. The x coordinate of the vertex. And then I'm going to say it, and I know I skipped the y-intercept, but I'll show you how easy that is. So as far as your note-taking is concerned, you can go in any order here. Since I'm talking about the vertex, maybe write that down real quick. And then as you're writing, input, say it, output. That's what this notation means next. If I get the x-coordinate of the vertex, how do I find the y? Input, say it. That's what this notation is. Function notation is just output notation. That's what this is. So this is the input. This is the notation for output in function notation. That's not an R. I don't know why I did a little curly Q on that. So that's what f of negative b over 2a means. Quick question. Say that again. This one here, the input output? Yeah. Okay, so the vertex x coordinate is what the axis of symmetry goes through. So the x coordinate's negative b over 2a. How do I find the y coordinate of the vertex? You plug in x and solve for y. That's what f of negative b over 2a means. Remember that this was called f of x up there. All right, so knowing that. Okay, so giving you a chance, since we don't do note sheets for the most part. Like I say, though, I think a good idea is to like cut and paste these little chart things that I've had in the 3 notations and put them on one document. And then that way you have all the forms in front of you. You get to fill it in again, from your own notes. You fill in your own. I'm not going to do it. You hopefully have good notes that you can translate and put your stuff and know what's supposed to go in there. That would be for tomorrow or Thursday. All right, now let's analyze the y-intercept. I wish I didn't have this shown. Y-intercept, you plug in 0 for x. That's for any graph, input, output. If I want the y-intercept, I would plug in 0 for x, because 0, comma, that's a point on the y-axis. So notice what happens when you plug in 0. I couldn't care less what a is. Because what's 0 squared times a, everybody? 3, 2, 1. 0. What's 0 times b? 3, 2, 1. So when I plug in 0 for x, what letter am I left with? 3, 2, 1, go? C, all by its lonesome. So a good thing, the only thing that really sticks out in standard form is what the y-intercept is. It's 0, comma c. Write that down now. Okay, pay attention. All right, so 0, comma c is the y-intercept. So wherever that number is at the end, that constant. So that's going to help in your evaluation for, finding other points other than the vertex. All right, and then the last part is not different. This is a reiteration of all the forms. Okay, if I have a parabola going up, then I have a minimum. But before that is the y coordinate of the vertex. That's how we name. The word minimum and maximum implies the y coordinate of the vertex. And then when there's a minimum, of course, a is positive. And then you would have a minimum because you have a parabola going up. So that kind of coincides with what we have in like box 2, I think. And if a is negative, just like the other forms. So that's what I mean about a having the same effect. Then a being negative would give you a maximum because you have a parabola going down. But the main thing with standard form is this magic formula, this negative b over 2a. Without it, you would not have anywhere to go. You wouldn't know what to do and how to graph this. Okay, you could get the y-intercept, but without having a vertex, you have no frame of reference, right? And that would be problematic. Okay, so here we go. That'll leave you alone today on a Monday. You just better, have that college student mentality that you need to pay attention and be in control of your own notes. So here we go. This is if you want it stepped out, this is how we're going to attack standard form. First of all, you find the vertex. And then again, this is the reiteration of, I got to know negative b over 2a, how to evaluate that, and then plug in that x value to find y. That's what this notation means. Input, say it one more time. Output. Of course, if I have an x value, you could find the y value by plugging in. Okay, make a 5-point xy table with the vertex as the one in the middle. That's the starting point. Find 4 other points. By the way, one of those points should be 0, comma c for your your chart. It makes it easy. And then also, I'm going to put the word use symmetry. And I'll show you what that means here, where you will have to evaluate less. Like you don't need to evaluate crazy here. If you have faith in what you're doing, you should use symmetry to reflect the points in your mind, the shared y values, the whole idea of what all parabolas have. And then graph the points, make a parabola, label the vertex axis symmetry. Probably have you write that in words. And only in this first example, we'll talk about domain range, increasing, decreasing. We'll verbalize it in the next couple. Working with Math 3 students right now in the tutoring. I love it. Actually, it's Math 3 honors too. So, and they're doing a lot of that. They're doing domain range on not just parabolas, a whole bunch of different graphs. Domain range, increasing, decreasing, and then also positive and negative. And I'll talk about that a little bit today. Okay, first of all, let's see how the class responds to this. Here's our first example. What is B? 3, 2, 1, go. 0. Did you hear? I just want to see how many people knew. B is 0 here. It's a missing middle term. So we are going to have to understand that A equals -2 for sure. C is showing up as 2. I don't know what's going on with my pen. I love it. It's random crap on my computer. And I don't have a middle term. So that means B is 0. And I did have that as a group response, like 5 people said something. All right, now understanding I don't have any parentheses, so this is standard form. So we got to get it, and that is a nice descending order in case it wasn't, but it is. So the vertex, that's what we're going to start with, which actually takes care of the axis of symmetry as well. You don't have to write all these words down if you don't. We could just say opens up or down. By the way, what does it open? Up or down? 3, 2, 1, go. Down. So just say it's down. Don't have to write all that opens up or down. And then is it stretched or shrunk? Let's ask that. 3, 2, 1, go. Stretched. So it opens down. It's stretched by a factor of 2. You don't say -2. And then we can move on and find the other information. All right, so finding the vertex, that magic formula. You either do it or you don't. -b, oh no, over 2a. I don't know if you need to type this on your calculator to figure this out or not, but you can divide by or have 0 up in the top. I almost said a bad thing. You cannot divide by 0. That's where your calculator, if you did it, would say math error. So 0 over a number is 0. Anytime. You know what's funny? Hold on, I just said a lie. What's 0 divided by 0? Oh, this is interesting. Let's answer that in 3 seconds. You ready? Ooh, you look scared. What's 0 divided by 0? Everyone has to answer. 3, 2, 1, go. Ooh, I heard a 0. I heard an error. Did anyone say 1? That's kind of funny, yeah. 1 is a common thing to think because you have something divided by itself. It is still math error. Well, you can type that on your calculator if you have it available right now. If you type 0 divided by 0, it will still say error. You can never, ever divide by 0. You never have a 0 in the denominator. So, but I'm just hammered on the point. You can have 0 in the numerator. Can. All right, 0 divided by a number. You can type on your calculator 0 divided by 7. You'll get 0. Anyway, I hope you don't have to evaluate very, hard on this. How do I get the y coordinate? You plug in 0 for x, square it, add 2, you get 0 plus 2, which is 2. So I happen to have the vertex, which is also the y-intercept. So we do have to evaluate next. All right, so I'm going to put 1 and 2. And then I'm going to put -1 and -2, but I'm not going to evaluate -1 and -2. Symmetry. And I hope the dog, you don't have to plug these in and actually write this out. But if you do, go ahead. But there's input. Say it. So I inputted 4x to solve for y. And this one does say y, so it's not in function notation, which is okay. 1 squared is 1. 1 times -2 plus 2 is 0. Hey, happy accident. What is this? What is that for the graph? 1, 0, the x-intercept. So even in this form, we're not going to worry about x-intercepts and having to find them. But if they accidentally occur, great. That's where we come into chapter 4 in the solving. Finding x-intercepts when you're in standard form. Not your responsibility right now. By the way, symmetry. That should be 0 as well. Why? I'm 1 away from the vertex, sorry. So I went 1 away the other way from the vertex because of symmetry. That should be true. If you don't have faith in it, plug it in. By the way, I do want to plug this in. This is a common error with people evaluating. So I'm going to write this real quick. What's PEMDAS? Or what's the P stand for? 3, 2, 1, go. Parentheses. Okay, I have parentheses, but really it's the E. What's E stand for? Exponents. So I am going to cover this right now because people screw this up all the time. Should I take this negative times a negative and make that a positive? Yes or no? No, that is M. That is multiplying. Think about this as a negative 2 times negative 1. You can't multiply before you do exponents. So what's negative 1 squared, everybody? 3, 2, 1? I just said it, 1. 1 times negative 2 is negative 2 plus 2 is 0. So I do have to cover that because this is a major, major problem. Like it's a violation of PEMDAS, a grade school idea, if you take that negative times a negative. I'm not writing this in. I'm going to evaluate in my head. 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 plus 2 is negative 6. Guess what? This should be negative 6. Use symmetry. You should not have to evaluate more than twice, let's say. If you wanted to double check yourself, though, you could. Then I got my nice coordinate plane here. 0, 2. And then 1, 0. Happy accident that we did accidentally get the x-intercepts. 2, 6. Whoops, I went too far. I think I'm 8 here, so that's 6. And then that's my symmetry sound. All right. Then equation of the x as a symmetry, we could already put that. X equals 0. X equals the x coordinate. There's the axis of symmetry, usually drawn as a dotted line. Oh, we could have asked this before. What should I have had? And I have a maximum. All right, and that maximum value is 2 at x equals 0. And then I'm only going to do this on this one example. Down at the bottom, we're going to write domain, range, increasing, decreasing. And then I am going to talk about positive and negative, right, intervals. But we'll wait on that, like, to formally make you do that. I'll talk to the other teachers about that tomorrow if we're going to do that. But the domain, it's the same for all parabolas. 3, 2, 1, what is it? Oh, you weren't ready. Okay, so what's the domain, everyone? 3, 2, 1, go. Or the quick thing to say is what? Anyone? All real numbers, but then you guys are being good students and writing it mathematically with interval notation. Now the range, I do yell at this. We're doing range and domain and all this other stuff with my CAT students. It always makes me sad people that can't figure out range. Range is what variable? 3, 2, 1, go. Y. Look at the y-axis. Look at these coordinates. Look at that this y coordinate exists. This one, this one, this one. Does this one exist on the graph? No, there's no graph up here. Range is just saying what y values do I have in the chart. If I was going to do a chart, what would my chart have? What y values would my chart have? It'd have all of these if I did the chart to infinity, like a negative infinity for x, plugging it in. It'd have all these down here, but you got to name it in order of a number line. Number line, I'm pointing to a number line that doesn't exist in my room, but zeros here and negatives are over there. We got to go in order left to right. So what y values are covered? What's the number way down here, everyone? 3, 2, 1, go. All the way up to, what's that number right here for y? 3, 2, 1, go. 2. And then what do we put on 2? A bracket or parenthesis? It's a bracket because it is the last y value. I'm over explaining that because I have too many problems with students not knowing how to find range when you just have the picture right there. You know, and those CAT students, oof, they're going to be the end of me. Fumble. Hey, what's this? Increasing or decreasing? Increasing. Sorry, I didn't do the 3, 2, 1 thing, right? But that's describing the y's. You need to say the x's that input to get those output increasing things. All right, so you name the input that gets my increasing output. That's describing the output. The input is negative infinity to 0. Never, ever, ever have a bracket on increasing or decreasing. Remember the idea. What's the slope of the tangent line right at 0? What's that slope? What's the slope of this line right here? 0. That means it's not increasing or decreasing at 0 at that particular moment. That's the change of direction. So that's the idea of why we don't use brackets there. And then decreasing from 0, the x value, to infinity plugged in. Never name the y's, always the x's. Now, real quick, I wish I could erase that highlighter. I'm going to point up here. I'm just going to mention this. We won't write it down though. But where is the function positive? Again, it's talking about the outputs. Wouldn't you agree that these are positive outputs right here, right? This little chunk here. So the interval where this is positive is from here to here. It'd be from 1 to -1. Reverse that, my bad dogs, -1 to 1. And you would use parentheses again because at negative and 1, those are zeros. They're not positive nor negative. And then what's this chunk right here? Wouldn't you agree that those are negative outputs, right? The interval that creates that is from -infinity to -1. And then from 1 to infinity, that's where this is negative. So again, they're talking about the y's. What x's make that happen? That's what interval notation is. All right, just an introduction on that. Again, don't go crazy with writing all of A through F. Just let's go ahead and do the math. But first of all, let's think about it. Stretch or shrunk? 3, 2, 1, go. Stretch. Up or down? 3, 2, 1, go. Up. So these are things you should think about before you do it. Do you have to write it? Not necessarily, unless we ask what are the transformations. Will I have a maximum or minimum then? 3, 2, 1, go. There's actually going to be a minimum because it goes up, so we do have a low value, down here. That's the idea. So you don't have to formally write that down. Just good to think about. Okay, -b over 2a. Why? Because I don't get it. There is nothing to get. There is just do. And that's not a b, that's a 6. So b is 6 and it looks like a b. Sorry. So -b over 2a. What do you end up getting for that? 3, 2, 1, go. -1. Input, say it. Now again, plugging in a -1, and you should not have to write this, but if you want to, fine. -1 squared is 1. Hold it. -1 times 6 is -6. So this is 1 times 3, 3. 3 minus 6 minus 2. 3 minus 6 is -3, minus another 2 is -5. So -1, -5. Again, if you wanted to write it, go ahead. If you wanted to keep track of your brain here as far as organizing your thoughts and making sure you don't make a mistake. That's what I verbalized, but I was able to picture that. You be careful. Any mistake on that? Hey, it's actually easy to catch mistakes. It really is, because if you get your vertex and it doesn't, your vertex ends up here and your points are all weird and it ends up going down as a parabola, you did something wrong. That's why we think about up, down, what do we have? Then if you do an evaluation mistake, your coordinates won't match. And then you have to go back and kind of relook at it. So that's kind of smart. I just thought about that randomly. Hey, why would we do this one no matter what? 0, 3, 2, 1, go. All right, we'll start over. So 0, 3, 2, 1, go. -2, you shouldn't even have to evaluate that. Okay, and then guess what? Symmetry. One this way, one this way. -1 to 0 is one right on the x-axis. -2 is one left on the x-axis compared to the symmetry. That's why that's smart. And then 1, I'm not going to write this down. 1 squared is 1. 6 times 1 is 6. So 1 squared times 3 is 3 plus 6 minus 2 when I plug in 1. That's 7. 1, 7. Come on, you stupid program. And then -3, 7. Then you'll see when we graph this, that symmetry is in action. So -1, -5. Wrong. -1 comma -5. 3, 4, 5. I almost went on the wrong side. And I would have caught myself. If I accidentally went 1 comma -5, that vertex is in the wrong spot. So I went 1 right on accident. Because then this wouldn't shake out very well. 0 comma, come on, program. -2 comma, symmetry. And then 1 comma 7, this is getting really stretched. 1, 2, 1, 2. -3 comma, right? And then this is parabolic. The points do make sense. If you make a mistake on evaluating the vertex and then do the other coordinates correctly, that's going to be all jacked up. It's not going to make any sense where that vertex is. And I get that all the time too. People that just can't evaluate very strongly. All right, axis of symmetry is not -1. It's x equals -1. I will mark you wrong. You're gone. All right, that's a lack of math syntax there. The minimum value is, -5 at x equals -1. And then we're just going to verbalize the domain and range. I'm going to, you don't have to. Domain, all real numbers for every single parabola. The range, in this case, the range has a minimum and goes forever up. So it's bracket -5 to infinity is the range. -5 to infinity with a bracket on -5. Decreasing from -infinity to -1, parenthesis. Increasing from -1 to infinity. That graph increases when we plug in -1 to infinity for x. All right. Wait for a second. Then I got to get stamping. Did we get out at 30? I'm already behind. I had 15 minutes left first hour. Okay, so we're going to go fast. The opposite of b over 2a is -4 over 2 times -1. I don't know where all my time went. I felt like I was fine on this. I know stamping isn't going to... I'm going to do even less stamping with you guys, and I'll just have to pick it up tomorrow. All right, -4 over -2 is 2. 2 comma. Okay, be careful with evaluating. I guess I'll wait till I have a negative number. I made a big point of this. Say we were evaluating, and I'm going to go ahead and type this in. But here's a big thing with PEMDAS, because I don't know if I'm going to have to plug in a negative when I do this. What if this was negative? It's not, but what if it was? And then this is what I had to plug in. PEMDAS, what's the P stand for again? What's the next thing? E, what's that? See, here's the thing. I get students that cancel these negatives all the time. That's M. PEM. That's multiplying. So no, you don't cancel these negatives. You square the negative and get a positive, and then you slap a negative on that thing. So I just wanted to make a point of that. Even though this is not negative, you've got to evaluate correctly using that grade school PEMDAS idea. So you square that negative, then slap on that negative. This is like -1 times. Okay, but I don't. So 2 squared. And then another thing, you have crazy people out there if you're squaring this negative. No, that negative's on the outside of the squaring. You square first, and then you multiply by -1. So this becomes -2 plus 8 minus 3. So -2 plus 8 is 6. 6 minus 3 is 3. 2 comma 3. Just want to make sure. We should know this. Opens down. There is no stretch or shrink. Since it opens down, we will have a maximum. So these are just things to think about, as far as how you should be thinking as you move forward. So I just want to make sure -2 plus 3 is -5. Yep. Oh. All right. Sorry about that sneeze. That came out of nowhere. 0 comma 3 2 1. What is it? -3. That's how fast it should be. By the way, I went 2 away. So 2 away the other direction should be 4 -3. 2 1 0 2 3 4. All right, and then we'll plug in 1. Okay, then be careful. 1 squared is 1, but negative. Ooh, happy accident. -1 plus 4 minus 3 is 0. We accidentally, again, ended up with the x-intercepts. It was a happy accident. 2 comma 3, 2 comma 1 2 3, 1 comma 0, 3 comma 0, 0 comma negative 3, 1 2 1 2. That's how I do it. I feel like I did something wrong there. Hold on a second. Let me just double check. 0 comma 2 comma 3, because that's kind of like a V situation. Let me just make sure for a second I didn't make a mistake. 2 squared is 4. Negative 4 plus 8 is 4 4. Isn't this 2 comma 1? Yeah. Wow. What a bad evaluation. You notice how I caught myself? That graph doesn't. These. This is too far away. This is like a straight line there, and that doesn't work. I knew there was something wrong there, and I caught my mistake. Maybe I did that on purpose for no purposes. Huh? 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 I didn't. That was a big mistake. Okay. So yeah, we should get that first order difference, and then it starts taking off, and we get that curve. I'm actually kind of glad that happened though. I caught myself. I knew something was wrong because I knew that the second set of points should be really stretched out more. They don't go like linear like that. So blah blah blah. So x equals 2. So I'm yelling at you, evaluate correctly, and I don't even evaluate correctly. All right, and then minimum maximum value. You have a maximum at 1 or 1 of 1 at x equals 2. So good thing I made that change. So I evaluated the vertex incorrectly for the y coordinate. Bad. All right, I think that's good. There's this random word problem that is not in standard form. What form is that? What form is that immediate without reading the question? Vertex. I almost made a mistake. Part of our, I love this. I think it's either this or chapter 4 or combination of the two. There is a formula that deals with gravity. When I throw a ball up, what happens to that ball? It goes up, and then what? Why? Because of gravity. If you're on Jupiter, first of all, you'd be crushed instantly into a point, all right, because that's crushing gravity and air pressures and all that other stuff. But gravity is different depending on the size of the planet and maybe some other factors. But this isn't what's going on here. Look at the x and y axis. This person's throwing the ball out. So the input, which is weird, is how far away from her body this ball is. The output is how high the ball actually goes. So what does the vertex tell you? The maximum height of the ball will be 3, 2, 1, go. 8. Those that said 8 feet are correct. So what this says for the vertex is when the ball is 2 feet away from her, it will reach a maximum height of 8 feet. Max height. That's not standard form. That's vertex form. Okay, so kind of a weird random word problem in the middle there just to analyze. And just think, just because we're doing all standard form, there might be some vertex forms inserted in the homework. Okay, homework's on the calendar. It is a book assignment.